So I'm going to talk about why dev and test, and then some of the research that we did and some of the challenges that we found and how cloud computing can solve those. And then Rocket's going to talk about the solution pack that we announced recently, and I think give you a demonstration of how easy it is to actually spin up some servers in the cloud to support dev and test. So every time we do surveys, dev and test ends up one of the top 2 use cases, ends up one of the top 1 or 2 use cases. And so why is that? I think first is it's a very easy first step into cloud computing. Rather than put production applications on the cloud, it's much easier to put a development project out on the cloud. Well, let me just show you a quick quote. I think James Governor said it best. It makes a great deal of sense to start with dev and test and go from there. Don't tell the customer to immediately migrate everything to and run everything on the cloud, which would of course be insane. On the contrary, recommend a low barrier to entry approach. Production is an end state where the customer finally just says, remind me again why we aren't using this flexible infrastructure as a production environment. So I think if you start with dev and test and then gradually move into operations, people will say this, why aren't we just doing more over here on the cloud? The second reason I think that it ends up being really popular is that the very nature of testing lends itself well to what the cloud is good at, and that is scaling. You need a bunch of resources, you go get them. You don't need them for a few weeks, you put them away. These stats from IBM, our partners at IBM did some research, and they found that 30 to 50% of hardware today is dedicated to testing, and that hardware stays idle 90% of the time. So rather, I did the same thing when I saw this. So rather than have a bunch of hardware, a huge investment sitting idle, it makes a lot more sense just to go get servers on the cloud, do your testing, and then come back. And then I think third is there are just some real challenges now with development environments and test environments that can be solved with cloud computing. And so that's what we'll talk about today. So here are some market trends. We did a fair amount of research as we were thinking about the solution pack. And here are kind of 2 big trends. One is that release cycles are shortening. When I started, we had 18 months to get a product out the door. By the time I left, we had a year to get the product out the door. At RightScale, we get new features out every 6 or 7 weeks. So even companies that we talked to that hadn't embraced agile development were shrinking release cycles. So their development organizations needed to be much more agile. The development process needed to be really streamlined so there weren't any places that developers got stuck and were waiting, especially waiting for equipment. The other thing is that it seems like all development organizations are geographically dispersed. Do we have anybody here with a geographically dispersed development organization? Yep. We have Russia, Florida, Texas, I think that's another state, another country these days. California, we've got groups of professional services in Europe and Southeast Asia, so we've got this in spades. And then here are some more kind of specific challenges. No one feels like they had enough resources, so developers and architects can't just get equipment to test out new technologies, can't just get enough equipment to really test out an alternative architecture. A lot of the equipment is shared, so there's a lot of configuring, reconfiguring going on for each task and project. The lead times for getting new equipment, we heard 3 to 5 weeks in a medium to large size company. And then just maintaining consistent environments through the cycle continues to be a persistent problem. That as software travels through the life cycle, with it travels environmental information, configuration information, and changes to that information in later stages rarely ever made it back into the earlier stages. So people found that as the next versions coming through, some of the same issues are reintroduced. And of course, no one has just one stream of software moving through. You have multiple streams, sometimes multiple target production environments. Sometimes problems happen in production, you have to recreate old environments. So a lot of time when we talk to these people, a lot of time was spent just dealing with configuration information. So what we're going to talk about is how you can use the virtually unlimited resources available on the cloud and then use RightScale to provision those resources and manage configurations through the life cycle. And by doing that, really be able to deliver higher quality software to your users in a shorter period of time. So what we have been working on at RightScale, we have a user interface, a very easy to use user interface where developers and testers can simply go out to the cloud and launch a fully configured all-in-one environment, so the entire stack on one server, reach out to a code repository, grab the code, do integration testing. Once they need more complex architectures, they need to start breaking apart the tiers, creating multi-server architectures. They can launch those same kinds of environments very easily on the cloud using RightScale. And then what's really great is once that software moves into production, the systems administrators, the operations professionals, can then use the full power of RightScale to manage, monitor, and automate those production applications. And unlike some of the past environments, RightScale works on infrastructure as a service clouds. So the operations people have complete control and complete visibility into all levels of the underlying infrastructure. We can also help maintain configuration and environmental information. So if you think about when you start a development project, you build a reference architecture. It specifies versions of software to be used, libraries. It has an architecture associated with it. All of that can be instantiated in RightScale scripts, server templates, and deployments. And we'll talk about the three of those in just a minute. And then as you go through the development cycle, it's very easy to take those modular components apart and repackage them to get exactly the configuration you need at any stage. The scripts and server templates are version controlled, so any changes made in any one stage are very easy. They're very easy to replicate in other stages. And the deployments, the whole environments, can be archived, so it's easy once you hit production to recreate an old environment if you need to do that. And here's kind of the underlying technology. If you were here in the morning, a couple times people referred to server templates. They describe how a server gets configured and how it behaves in the cloud. And so this is a kind of a simplified version, but we think of it as kind of a base machine image that literally just puts the operating system on and puts a lightweight agent called WriteLink on the server, and that communicates with RightScale. Then there are a series of scripts. Some of them run at boot time. Those are usually the scripts used to install software. Some of them can be run while the server is operational at any point through its life, and that may clear caches or backup databases or, I don't know, update software. There are a whole bunch of things that can happen. I think Ross is going to show you how it can sort of update, go out and grab a new version of code to put on that server. And then decommissioning scripts simply ensure that any server is gracefully decommissioned and that any kind of data that needs to be saved on that server is put in permanent storage. So then we take these basic building blocks, scripts, the server template, and then we bunch server templates into what we call deployments, and all of those can be unpackaged and repackaged. So let's see if I can make a pointer work. Right there. So here you have an app server, a database, and an operating system. So that would be a machine image and two scripts inside a server template, and that's what could be used to set up an all-in-one server for integration testing. As soon as you move to more complex architectures, you can take those same scripts, package them with the machine image to put the operating system on in separate server templates, and those can launch separate servers now. Now let's say you need to be a little more complex. You want an array instead of just two app servers. So you can use the same server template that you used to launch app servers in the prior configuration to launch individual servers as part of that scalable array. You can use the same database server template to create a master database or a slave database. So what's great about the way RightScale is architected is that all of this is very modular, very componentized, if that's a word. So you can just unpackage and repackage things. And because it's all version controlled and can be archived, it's very easy to manage changes through the process.
So in RightScale, we have what's called a solution pack, which is a package or a base RightScale system, which gives you a bunch of functionality. In the development and test solution pack, you have a library of server templates that we've already created for you. And so we create the two types of configurations, an all-in-one server which has the database and the app server all on the same server. And we've created this deployment which has a multi-server deployment of a load balancer, a couple of app servers, and a simple one server database. And we've done those two types of deployments on PHP, Java, Rails, and .NET. So as part of the Dev and Test pack, you can choose whatever environment that you are using for your development, and then when you have those, you can select which of the two types of environments that you, as a sysadmin or a developer, wants to stand up. As part of the Dev and Test pack, you also get two kind of views into the RightScale system, or the RightScale dashboard. You have the full dashboard, which the sysadmin or the DevOps person uses to be able to take the server templates, change them, be able to customize them for the environment of your company and your development environment. And we also have a self-service portal. So once the system admin or DevOps person has created these customized server templates that your company can use that specifies your application, then a developer or a tester can go in and launch all-in-one or a multi-server environment without the help of your sysadmin or DevOps person. So that self-service portal does not allow them to make changes to the configuration of the server template, but it allows them to basically do all the operational things that you need to do to start your server, to maybe run any of those operational scripts that we said, like to back up your database server, anything that you need to manage your server, and to also shut down the server. So they actually have full lifecycle control of the server, except they just can't change the configuration. So the sysadmin or DevOps person completely controls that for you. And of course, if you have a small development group, you might not even need the self-service portal. You just make everybody sysadmins, and they're free to do whatever they want. We've also started working with our partners, and we've started with Zend and IBM, but we're actually building a whole ecosystem around Dev and Test. But with Zend, if you know Zend, they have an enterprise supported PHP server where you can actually profile PHP code, you can do debugging, and it's full support. And so they have server templates that they've created, that they've contributed to the RightScale library, as well as IBM for WebSphere and DB2 have also contributed server templates. So you're able to stand up a multi-server or an all-in-one server for those two environments as well. And going forward, we'll have more and more partners providing their server templates.